My name is Tom Healy, and on behalf of the ICMA, thank you for joining this presentation of the ICMA Common Domain Model for Repo and Bonds. The Common Domain Model is a standardized data and processing model that represents how financial products are structured, traded, and managed across the transaction lifecycle. Key feature of the CDM is not only that it is built using a machine-readable, domain-specific language, but it generates executable code that can be integrated with existing applications and systems. The CDM is now open source on GitHub and supported by Finos, the FinTech Open Source Foundation. The objective of ICMA CDM project is to support market efficiency, promote interoperability, and foster innovation. The ICMA expanded and modified the existing model developed by ISDA for derivatives throughout two project phases that added repo products and lifecycle events. CDM now enables firms to automate trade, execution, clearing, settlement, and associated lifecycle events. The CDM covers a broad range of financial products and standardized services that have been developed through collaboration by ISDA, ICMA, and ISLA. The CDM supports more than just transactions, but includes provisions for legal documentation such as GIMRA and industry best practices. A key aspect of the CDM is that it is vendor, platform, and programming language agnostic. The CDM can be implemented consistently across platforms used by sell-side, buy-side, venues, and service providers. The CDM is more than a data model. It contains predefined processing logic for executing trades and related lifecycle events. The CDM is especially important for fostering technology innovation, saving development time and resources. The CDM supports industry standard messaging and data schemas and implements data transitions between industry standards and the CDM. Messaging standards and external interfaces can be designed using extensions to the CDM, utilizing the CDM domain language and utilities for mapping and translation without changing the core model, and thus maintaining consistency and integrity of the model. A common implementation would utilize web service interfaces to further improve interoperability across participants. The CDM is capable of being integrated across many applications and different levels in the technology stack. As an example, a user interface can translate a CDM JSON object into a representation of inputs required to execute a trade, or it's possible to exchange CDM objects in data feeds. Modeling in the CDM is currently performed using a domain-specific language called Rosetta from Regnosis. As an open source product, it is intended that the CDM will support other DSLs and development platforms. Here's an example of a typical CDM data type or class that represents a trade with a product, parties, execution details, and contract details. Running the DSL through the CDM parser and code generator results in executable software. In this example, Java code is generated, but other languages are also supported. The repo market consists of many participants. Cash borrowers are typically hedge funds, banks, primary dealers, and prime brokers. Cash lenders are fund managers, asset managers, insurance companies, and banks as well. The industry is supported through a number of service providers that provide trading services such as sponsors, agent lenders, and venues, settlement services, and reporting. The flows between the counterparties and the service providers include execution details, confirmation, securities transfer, cash transfers, interim payments, margin calls, terminations, term changes of contracts, netting, pair-off, and shaping. The existing ISDA CDM for derivatives was extended to include repo-specific data types, attributes, and processes. The existing interest rate payout that was used for derivatives was reused for the cash side of the repo transaction. A new payout called asset payout was added to define the collateral side of the repo transaction. Other enhancements include termination provisions for early terminations, evergreens, and extendable, and a new taxonomy structure for asset classification and functions for lifecycle events. Repo lifecycle events were added in phase 2 of the ICMA CDM for repo and bonds. The typical repo lifecycle begins with an execution. Then there's an allocation of collateral or an allocation to multiple accounts. The next step may be to pair the trades, which matching buys and sells to reduce exchanges of cash and securities, shaping that breaks trades into smaller pieces. Throughout the life cycle of the trade, there may be other events like rolling, substitution, early termination, reprice, re-rate, interest payments, or extensions of the maturity date. Trades and associated life cycle events, such as a change in the interest rate, substitution of collateral, are built into the CDM. Having predefined events is a key feature of the CDM. It helps maintain consistency across all participants and automate manual tasks such as reconciliations, confirmations, and operational best practices. In the CDM, this is done using a set of predefined primitive instructions that are packaged together to create a business event. Primitive instructions that are pre-built in the CDM include creating a new trade, transfers, quantity changes, rate changes, party changes, and external observations that are used to reference external events. The design principles behind the event model are that a life cycle event describes a specific state transition. State transitions are functional and composable. The history of the trade state can be reconstructed at any point in the trade life cycle. The product underlying the transaction remains immutable, and the state is trade specific. Now I'll demo the CDM in action to perform repo executions and lifecycle events. First, I'll explain these events and how they are executed. A repo roll involves an event of closing an existing position and reopening a new position with the same contract details on a new maturity date, and optionally a new price. Here we have a repo with an initial term. The same trade is then rolled for the same term to a new maturity date. In the CDM, this is performed by splitting the trade to make a copy for a new trade, closing the original trade, and then instantiating the new trade with a new maturity date. In a rate change, the counterparties have agreed to change the rate or spread of an existing repo transaction. This will typically occur on an open repo or other cases where the parties agree to set a new rate or spread without terminating the trade. To execute a rate change in the repo, we'll split the trade, open a new trade, set a new rate without exchanging cash or securities. And finally, an early termination. Open repos or term repos with an early termination option, or when agreed to by the counterparties, can invoke an event to terminate a contract on a date earlier than the original termination date. Here we have a repo with a fixed maturity date. One or both parties invoke an early termination option that will terminate the trade based on the notice period. In this case, the original trade is closed, a new trade is opened with a new maturity date without exchanging cash and securities until the final termination occurs. In this demo, I'm using an Excel application with a web services interface to the CDM running on the Regnosis platform. The upper left screen represents the repo trade ticket that I'll use to interact with the CDM. On the bottom screen is the event panel where the lifecycle events from the CDM are posted. Firstly, I'll initiate a new trade, which is an overnight repo. But because today is a Friday, the maturity date will be reset to Monday. To perform an execution in the CDM, you need to pass in several parameters that will create a primitive instruction. This is an example in JSON format that represents the parameters of the CDM that are needed to pass in to create a primitive instruction. It contains the product definition, contains the quantities of the trade, contains the counterparties on the trade, and any other details related to the execution. I'll pass this into the CDM by booking the trade. I call the web services interface to create an execution instruction. I get the execution instruction, which I then pass back to the CDM as an execution of a business event. I now call create execution, which is creating the business of executing the business event. And we can see these events in the event blotter from the CDM. I'm now going to roll this trade. So this trade started today on the 14th and was terminating on the 17th. It was a 3-day trade. So now I'm going to roll this trade, which will change the start date to the 17th and roll the trade to the 20th. To do this, again, I create a set of parameters that are going to be used to create a roll primitive instruction. And I call the web services interface roll primitive instruction. I get back the primitive instruction set, which includes the original trade that I did and the details of the new trade. I take the primitive instructions, which are then passed back to the CDM, calling create business event. Business event is then created. The trade is now rebooked with a start date of the 17th and a maturity date of the 20th. I'm now going to re-rate this trade. Again, I'll construct a set of parameters to call the CDM function, on-demand rate change. This will create a primitive instruction set. Primitive instruction set is returned to the application, which then builds a business event instruction. Then called create business event with that instruction set. We now modify the trade with a new rate. You can see in the event blotter that first we called create on-demand rate change, and then we called create business event. Lastly, I'll demonstrate the early termination. But first, I'll create a new trade. With a maturity date of approximately 2 weeks. I'll now invoke the early termination option, which was part of the contract, with a 2-day notice period. So this contract will now be terminated early by moving the maturity date from the 28th until 2 days, which is the notice period. In this case, 2 days would be till Sunday, so the termination date, maturity date, will be moved to Monday. So I'll call the CDM to create a cancellation primitive instruction. Using the primitive instructions, I'll then package that into a business event, call the CDM to call create business event, which will then execute the termination of this trade. We now have a trade in a new trade state with a new maturity date of the 17th. We've now completed the full life cycle of a trade, from execution, roll, re-rate, and early termination. While this is a fairly basic example, it demonstrates how the CDM can be used across external platforms and internal applications. The CDM supports automation of a wide array of repo transactions and related lifecycle events. The CDM is available to all interested parties under the open source license in Finos. Thank you, and please reach out to us with any questions or comments. Thank you.